we say that it has gained a property, of attracting very little things, and that property is called that it is charged. So charges are of actually two types: positive charge and negative charge. Charges are of two types: positive charge and negative charge. Two little properties of these charges are this: that this positive charge attracts negative charge, positive charge attracts negative charge, and negative charge attracts positive charge. Okay, now if we are talking about this electric dipole, so electric dipole means di means two, and pole means whether it is a positive charge or a negative charge. These are called dipole. Dipole means whenever a positive and negative charge, they are separated by a very small distance, then we say that a dipole is formed, an electric dipole is formed. So how it is made, let me tell you how it is made. This is a negative charge, this is a positive charge, negative charge and positive charge. And whenever this positive and negative charge, whenever they are separated by a very small distance, we say that distance as small distance, we take this small distance as 2a. Then we say that an electric dipole is formed. Electric dipole. Now, why this word dipole? You have seen a magnet. You have seen practically also so many times you have seen magnets. Small children also play with magnets. So in magnet, we have a bar magnet. Bar magnet is like this. Bar magnet is like this. It is a rectangular piece of magnet, and it has two poles. One pole is called North Pole and another pole is called South Pole. When we talk about electricity, then we very frequently we come across a term called magnetism also. Whenever there is electricity, if electricity exists in a cable, in a wire, then magnetism also goes in hand with that electricity. Whenever there is magnetic field in any region, then we say that a magnetic field can produce electricity. So magnetism and electricity, they always go hand in hand with each other, and that's why we call them electromagnetic radiations. So if we compare both these things, then a magnet is called a magnetic dipole, because a magnet always consists two poles together, North Pole and South Pole. Just like that, we are comparing this positive charge with the North Pole and this negative charge with the South Pole. Why? Reason is this: in magnetic lines of force, you have studied it in class 10th also. Whenever we say about magnetic lines of force, then magnetic lines of force always originate from North Pole and go to South Pole, like this. Similarly, electric field lines, these are magnetic field lines. Electric field lines always originate from positive charge and they go to negative charge, like this. They start from positive charge and go to negative charge. Okay, one more thing. When we talk about this magnet, then in magnet, these magnetic lines of force, externally they start from North Pole and end at South Pole, but internally means inside the magnet, they go from South Pole to North Pole. Actually, they are closed loops. Magnetic lines of force, they are closed loops. So in this way, we say that if we take a negative charge and positive charge, negative charge behaves like South Pole and positive charge behaves like North Pole. So in an electric dipole, we say that from negative to positive, the direction of negative to positive is called dipole moment. is called dipole moment. Now see, this dipole moment is given as electric dipole moment it is given as p vector, small p vector, and it is given as q multiplied by 2a, q multiplied by 2a. And whenever we say about what will be the SI unit of this electric dipole moment, then it will be very easily calculated. It can be very easily calculated. The unit of q means charge. What is the unit of q? It is coulomb. C. And what is this? 2a. 2a is what? 2a is length. What is the unit of length? Unit of length is meter. So SI unit of dipole moment is coulomb meter. So let's repeat it once again. An electric dipole is made up of two equal and opposite charges. Negative charge minus q and positive charge plus q. An electric dipole is made up of two equal and opposite charges separated by a small distance, and we from this electric dipole we come across a new term which is called electric dipole moment. Electric dipole moment is calculated by multiplying either of these two charges, q into distance between these two charges. So q into distance between the two charges gives us a new term which is called electric dipole moment. Is it clear? Is it clear? Okay. Then do you have any idea about electric field? Electric field?
The field around. I don't understand the question.
Okay. Let me tell you. Actually, I am asking about what is an electric field. Electric field is a field. Electric field is an area, is a field where the presence of electricity can be experienced. Where the presence of electricity can be experienced. That is called electric field. Okay. So, we want to calculate electric field due to an electric dipole. Now look. Electric field due to an electric dipole. Electric field due to an electric dipole. If we take a very little charge, a small charge, so small charge, say it's q, and this small charge q is placed at this point, and if we want to calculate electric field at a point, say p, if we want to calculate electric field at this point, then electric field can be calculated as, the formula of electric field is 1 upon 4 pi epsilon naught q upon r square. Okay, what is this r? We have charge. The charge is placed at this point. And from this point, we want to calculate electric field at this point. So the distance between A and P is called r. This is the distance r. Okay, and electric field is 1 upon 4 pi epsilon naught q upon r square. This is electric field. Now, so this is the case of a point charge. When we have a point charge, when we have a single charge, but if we want to calculate electric field due to a dipole, then it can be calculated in two different ways. So onto your notes, you can go on page number 35, electric field at an axial point of a dipole. Electric field at an axial, next page, electric field at an axial point of a dipole. So there are two types. Electric field can be calculated in two ways. If the point where the electric field is to be calculated is on the axis of the dipole, so first at an axial point. At an axial point. What is this axial point? We have a dipole like this. We have a dipole like this, minus q and plus q. Okay. Where is the midpoint of this dipole? Let's mark the midpoint of this dipole. The midpoint of this dipole is this. Let us mark it O, this point. Let us mark this point as O. Wait a moment. So this point is minus q, this is plus q, and let us mark this point as O. This point is O. Okay, I am on page number 35. Electric field at an axial point of a dipole. We are talking about this topic. So let us take a point. Let us take a point P here. Let us take a point P here, and this point, probably we are talking about electric field at an axial point. So we will take point P on the axis of this dipole. On the axis of this dipole, this point P. So we have taken it on the axis of the dipole. Okay, whenever someone asks us ki, if we are standing on a road, and someone asks us that what is your distance? What is your distance from that car? What is your distance from that car? If to be very precise, you may ask two questions. We are standing here, and here there is a car. So if you are very precise, then you will ask, you are standing here and here is a car. You will ask, okay, this is my location, this is car's front and this is car's backside. This is car's front and this is car's backside. So I have to measure distance. I have to calculate the length from here to here or from here to here. So this is the problem. This is the problem. If we want to calculate the distance, if we want to measure the length, then we say that if we take the midpoint, we take always we take the midpoint of any bigger object. If we have a point object, then it is all right. Then it is not a problem. So if we have a bigger object and someone says that you calculate the distance, then we say that okay, this is the center of mass of this point. This is the center of mass of this point. So from this point, the distance is calculated. Similarly, whenever we say that we have an electric dipole and we want to calculate an electric field at an axial point of this dipole, so we will take, first of all, we will take a point on the axis of this dipole. Okay, we have taken that point as P. Now we will mark the center of this dipole because we want to measure the distance. So from which point we have to measure the distance? From this point or from this point? We say that generally speaking, we will take the distance from the center of a dipole. So we have taken the center as O. So from here, we will take the distance as R. This is a standard notation of measuring distance in physics. Whenever we measure distance in physics, then we take the distance as R. All right. Now, what we will do? This is A, and this is also A. Why? Because length of a dipole is taken to be as 2A. We do not take length of the dipole as A because it will create a little bit problem for us while calculating, because if we want to split it in two equal halves, then if we take the distance as A, then splitting it into two equal halves will give us two distances, A by 2 and A by 2. So A by 2 and A by 2, calculation with A by 2 and A by 2 a little bit problematic. That's why all the scientists have taken the distance as 2A. So we are also taking it as 2A. In all the books you will get the distance is taken as 2A. So this distance is a, this distance is a. Now electric field, electric field due to charge minus q, electric field due to charge minus q at point P is, electric field due to charge minus q at point P is E minus q. Okay. There is one more thing. Whenever we calculate electric field, whenever we find out electric field of anything, so if we want to calculate electric field, if we want to find out the electric field at point P, then what we do? We assume that a unit means one, a unit positive charge is kept at this point. Unit positive charge means 1 coulomb. So this is a standard thing, that whenever we want to calculate electric field at any point, then we say that at that point we assume a unit positive charge is kept at that point. We assume that. So E minus Q means what will be the electric field at point P due to this charge. ठीक? So it will be 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught, this is the electric constant, 1 upon 4 pi epsilon naught, charge is minus q upon distances from here to here, distances r plus a, r plus a's whole square. Okay. Now, whenever we talk about electric field, then we do not take the sign as minus q or plus q. Then why this minus sign has been taken? I will tell you. First of all, remove this sign minus q. Okay, let's keep it. I will tell you. Actually, what happens? This is a positive. Whenever we wish to calculate electric field at a point, then at that point we take a unit positive charge. So this is negative charge. What this negative charge will do to this positive charge? It will attract it. Negative charge will attract it. So direction will be leftwards. Direction of electric field will be leftwards. So E minus Q vector, E minus Q will be leftwards. You understood this point? And whenever we say about this horizontal axis, then we say that this horizontal axis is x-axis, and anything which we take onto the right is taken as positive, anything which we take towards left is taken as negative. That's why this negative sign is here, and that's why it is written towards left in the bracket. P cap. Now I will tell you this, what is this P cap also, just wait for a moment. Towards left. Actually, P vector is dipole moment. And P cap is unit vector along dipole moment. Unit vector gives only the direction, it has magnitude of 1. So P cap, actually the direction of dipole moment is from where? It is direction of dipole moment is always from negative to positive. And E minus Q is, this one is positive, unit positive test charge. We always keep unit positive test charge at point P, where electric field is to be calculated. So this direction, this negative charge is attracting this positive charge. So direction is from positive to negative. That's why this P cap is negative. Okay. This negative sign must be with this P cap. Dipole moment is from negative to positive, and this negative charge is attracting this positive charge. So it is from positive to negative. That's why we have taken it negative. Now, similarly, we will find out the electric field due to this positive charge plus Q. E plus Q vector. Now again think E plus Q vector, E plus Q. So plus Q, what this positive charge will do with this positive charge? It will repel it. Positive repels positive. It will repel it. So electric field will be like this. E plus Q will be like this. Okay. So how will this electric field will be calculated? E plus Q is equal to 1 upon 4 pi epsilon naught. 1 upon 4 pi epsilon naught. Q upon charge, we take only the magnitude of the charge, not the sign. Sign we take by looking on the direction. So 1 upon 4 pi epsilon naught Q upon, now this time the distance will be r minus a. How? We have to take this distance, only this distance. This distance. So distance from this place to this place is r and this one is a. If we want to take this distance, then from r we have to subtract this a. Understand? Acha, Anusha, are you getting everything which I am telling you?
Yeah, I'm understanding.
Are you understanding? If
Yeah.
if you feel any problem with my voice or anything which I explain here, you may intervene in between. Okay? Then only we will move forward.
Question.
Hmm.
The E plus Q and E minus Q is like the effect of Q on like point, like why are we doing E minus Q and E plus Q?
Okay, wait. What is this E minus Q? E minus Q is what is the electric field at point P due to this charge minus Q? This is E minus Q. Electric field at point P due to charge minus Q. This is E minus Q. Understand? Similarly, we are taking E plus Q. Electric field at point P due to this charge plus Q. So E plus Q is 1 upon 4 pi epsilon naught charge is Q and distance is R minus A upon R minus A ka whole square. Now, what is the direction? This positive is going to repel this positive. This positive. The positive is going to repel this positive charge. So when it is going to repel it, so it will be in this direction. E plus Q will be in rightward direction. So rightward direction is from minus Q to plus Q, and this is the direction of this dipole moment. So now we will take it plus P cap. This is clear? Is this clear? So now we will take it as plus P cap and we will write as towards right. Towards right. So what this whole system consists of? This dipole consists of only two charges. So we have calculated electric field due to this charge. We have calculated electric field due to this charge. The total electric field will be the addition of these two charges. So we will say it E axial is equal to E minus Q plus E plus Q. E minus Q plus E plus Q. What is this E minus Q? 1 upon 4 pi epsilon naught minus Q 1 upon 4 pi epsilon naught minus Q. Let us take this negative sign from here to here. We can take it minus Q upon R plus A's whole square P cap plus E plus Q is 1 upon 4 pi epsilon naught plus Q upon R minus A's whole square P cap. Now we can take 1 upon 4 pi epsilon naught here. 1 upon 4 pi epsilon naught is here also and here also. Q is here also and here also. So we can take Q upon 4 pi epsilon naught common. Q upon 4 pi epsilon naught common. So what will be left over here? If we take Q upon 4 pi epsilon naught common, then minus sign means minus 1 upon R plus A's whole square is left in this bracket, plus 1 upon R minus A's whole square and P cap. P cap we have taken P cap also common, and we have written this P cap onto the right of the bracket, and we have taken Q upon 4 pi epsilon naught common, we have written it onto the left of this bracket. Is it clear to you? Is it clear? All right. Okay. Now we will take the LCM. Whenever we have this type of different terms, then we take LCM. Then if we wish to take LCM, then we multiply these two terms. So Q upon 4 pi epsilon naught into LCM. LCM means multiplying these two terms, R plus A's whole square into R minus A's whole square, and multiply R minus A's whole square with minus 1, to minus R minus A's whole square plus R plus A's whole square and P cap. Are you comfortable in taking this LCM? Okay. Okay. Can we move on to the next slide? Okay. Okay, Anusha, can you wait for 2 minutes? I am coming in 2 minutes. Are you there?
Yeah, sir.
Okay. Now, this one, Q upon 4 pi epsilon naught, we have taken LCM of these two, R plus A's whole square into R minus A's whole square. So E axial is equal to Q upon 4 pi epsilon naught, Q upon 4 pi epsilon naught minus R minus A's whole square. Let us expand this R minus A's whole square. And keeping this negative sign outside the bracket, we will expand this R minus A's whole square. So minus sign is outside, R square plus A square minus 2RA. r plus a's whole square. So plus r square plus a square plus 2ra. A square plus b square plus 2ab, and a square plus b square minus 2ab. That identity we have used it here. Now r plus a's whole square into r minus a's whole square. So we will write it like this: r plus a into r minus a whole square p cap is equal to q upon 4 pi epsilon naught minus r square minus a square minus minus plus 2ra plus r square plus a square plus 2ra, okay, upon r plus a into r minus a is r square minus a square, and this one is r plus a into r minus a is r square minus a square and its whole square into p cap. Now plus r square minus r square plus a square minus a square. So q upon 4 pi epsilon naught 2ra plus 2ra is 4ra upon r square minus a squares whole square p cap. Yeah. Is it clear? Is it clear?
Yes,
Okay. Now we will do it like this: q upon 4 pi epsilon naught and 4ra. We will write it like this: 2r into 2a. We can write it 2r into 2a is 4ra upon r square minus a squares whole square and p cap. Okay, now let us take this q into 2a. Let us take this q inside it. So 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught q into 2a multiplied by r upon r square minus a squares whole square p cap. Now why we have kept this q into 2a together? Because we know that q into 2a is dipole moment. Is equal to 1 upon 4 pi epsilon naught q into 2a is p. Q into 2a is p, and this one is sorry, I have forgot to write 2r here. 2r. So p into 2r upon r square minus a squares whole square and p cap. Now when we talk about a dipole, then in that dipole the basic definition of electric dipole is this: two equal and opposite charges separated by a small distance. So the distance between negative and positive charge is very small. That 2a is very small. And if we are talking about that a, so a is half of 2a. So a is further very small. So since a is very small, therefore we can neglect a square. That is r square minus a square is equivalent to r square. R square minus a square is equivalent to r square. So this axial electric field, it becomes 1 upon 4 pi epsilon naught 2pr, p into 2r, you can write it like this also, 2pr upon r squares whole square, because a square is very very small that we can neglect it. So r squares whole square p cap 1 upon 4 pi epsilon naught 2pr, r squares whole square is r to the power 4, so r cube. So it is 1 upon 4 pi epsilon naught 2p upon r cube p cap. This is axial electric field of a dipole. Tell me, is it clear to you?
Yeah.
Is it clear? Okay. Uh, Now we have next topic, electric field at an equatorial point. Okay. Do you want to understand this equatorial point, or shall we discuss that electric flux? Whatever you say.
Quicker, whichever. Or like which one's easier?
Okay, both are easier, no problem. Okay, let's go with this only, equatorial point. So first of all, we have calculated this electric field at an axial point. Axial point means the point which lies on the axis of this dipole. Now equatorial point. At an equatorial point, electric field at an equatorial point. We have this electric dipole. Negative charge minus q, positive charge plus q. What is this equatorial point? Equatorial point means the point which lies on the perpendicular bisector of this dipole. The point which lies on the perpendicular bisector. Perpendicular bisector means midpoint and on the perpendicular line. That point is called equatorial point. We have taken this point here. Now on this point, this point do not lie on the axis. This point lies on the equatorial point. Okay, so let us take this point as A, this point as B, and this point, central point is O, and the point, the distance of the point, is taken as R. We take this distance as R. Okay, now this one, join this one and this one by dotted lines or bold lines, whatever you wish. Then the length of this dipole, the distance between negative and positive charges, the length of this dipole is small a. Here it is small a, this is also small a. And how to calculate this distance? This distance will be calculated by Pythagoras theorem. This is perpendicular, this is base, this one is the side which is opposite to this right angle is called hypotenuse. So this is under root r square plus a square. Similarly, the length of this side also is under root r square plus a square. R square plus a square. Now, at the point where we wish to calculate an electric field, we consider a positive point charge. Is kept at that point. Okay, so positive point charge P is kept at this point. So what this positive charge is going to do with this positive charge? It is going to repel it. So direction of E plus Q. Electric field due to this positive charge will be like this, E plus Q. Now, what this negative charge is going to do with this positive charge, always consider that a positive charge, positive unit means 1, positive means this plus sign. Unit positive charge is kept at this point. So what this negative charge is going to do with this positive charge, it is going to attract it. So it will attract it towards this side. So this is taken as E minus Q, electric field E minus Q. All right. Now we have taken this angle as theta and this angle is also theta. Okay. So there are two vectors, E plus Q vector and E minus Q vector. Are you able to see it clearly?
Yes, sir.
Okay, okay. Now this angle is theta. If we draw a line from the middle of these two electric fields, E plus Q and E minus Q, then it is like this. And this line is parallel to this line, then this angle is theta, and this angle is also theta. Alternate interior angles. This angle is theta, then this angle is also theta. Corresponding angles. That's why these two angles are theta theta. Okay. And E plus Q is here. The component along the angle is E plus Q cos theta, and component of E minus Q along this is E minus Q cos theta. Is this clear or shall I zoom it? Okay, okay. So E plus Q cos theta and E minus Q cos theta. And what about sine component? What about vertical component? E plus Q cos theta is here. So E plus Q sine theta will be like this. I am showing it, although it is not required, but I am showing it. E plus Q sine theta is like this. And E minus Q sine theta, E minus Q sine cos theta is here. So E minus Q sine theta will be here. E minus Q sine theta. Now, to calculate the net electric field, what we will do? We will add up all these components, E plus Q cos theta, E minus Q cos theta, E plus Q sine theta, E minus Q sine theta. What is E plus Q? First of all, calculate this. What is E plus Q? E plus Q is 1 upon 4 pi epsilon naught charge is Q upon this distance under root r square plus a square. Distance is this. So Q upon under root r square plus a square whole square. Q upon distance whole square. Okay. And its direction is like this. So we will write as along BP. Now E minus Q. One upon 4 pi epsilon naught. This direction is its direction is like this, from P to A. Q upon under root r square plus a square whole square along PA. Along PA. Its direction is from P to A. Are you getting it? Are you really getting it, or are you getting tired?
Yes, sir. No, sir.
Okay. Just wait for 2 to 3 more minutes. I am going to finish it. Okay. So net electric field net electric field will be E equatorial, E equa is equal to E plus Q cos theta plus E minus Q cos theta. E minus Q cos theta. And since these two components are onto the left, then we will take it, the sign we will take the sign as negative because they are towards the left. And we will not take these two components, E plus Q sin theta and E minus Q sin theta. Why? Because this is towards top and this is towards down, and if we add this top component and down component, then it will cancel out each other. Okay, it will cancel out each other. So we will take like this, we will take these two components only, E plus Q cos theta and E minus Q cos theta. Now minus sign and E plus Q cos theta, E plus Q is this and cos theta. So 1 upon 4 pi epsilon naught Q upon, when we take the whole square of a under root term, then whole square cuts out this under root. This is Q upon R square plus A square. Okay, plus 1 upon 4 pi epsilon naught Q upon R square plus A square. ठीक, and direction, we for mentioning the direction we will write p cap because it is from positive to negative and we have taken negative sign here, so we will simply write p cap. Okay, after this we have some calculation work. So if you say we will do this calculation work, or if you say we will do it tomorrow. Can you say it a little bit louder? Not...
We can do it tomorrow, sir.
Okay. All these, both these topics are clear to you?
Yeah, very clear. Thank you, sir.
Okay, Anusha. Okay.
Thank you, sir.
Okay. Bye.